Okay. Well, we are having some issues with one of our colleagues, Bruno. I hope he will join soon. In the meantime, thanks everyone for joining to this live stream. Today we will speak about from tech to application, demystifying high temperature heat pumps. We have here our two experts. We have Ivan, we have Benjamin. Benjamin, you are Innovation Director from the Danish Technical Institute. Thanks a lot for joining and taking the time for being with us. Ivan, you are Industrial Heat Pump Business Development Manager for Danfoss Climate Solutions. So please, Benjamin, can you maybe introduce you a little bit, say a little words about yourself?
Yes, hello everybody, and thank you very much for having me. My name is Benjamin Tylsov. I'm working as the Innovation Director for DTI, as you mentioned. DTI is a non-profit R&D organization. We're independent of technologies and companies, and we're on our side working a lot with industrial heat pumps, high temperature heat pumps. I'm here for around 7 years and have had a number of bigger R&D projects, working with industrial customers where we are both supporting technology development, but also integrating them at end users. And yeah, with that, I'm happy to be here and to discuss a bit on where we are with high temperature heat pumps and what perspectives we see for the coming years.
Thanks a lot, Benjamin. Ivan, your turn. Can you please introduce a little bit yourself?
Yeah, sure. Thank you, David. Hi, everyone. My name is Ivan. I'm responsible for industrial heat pump from our Danfoss Climate Solutions team. I have been with Danfoss for 8 years. My background is thermal engineering, and my focus has been dedicated to industrial heat pump solutions for the last, I would say, 3-4 years. This is where we saw the market really demanding development of new technologies, and we work closely with both our customers, OEMs, contractors, end users, also many research institutions and leaders such as DTIs. And I would like to thank Benjamin the possibility to join me today for this discussion.
Super. Thanks a lot. It seems like we are recovering our host, Bruno. Bruno, can you hear us? Hello, Bruno. It seems like we are still having some technical issues from his side. Okay. Well, anyway, as I said, this is a live stream that we are doing in accordance with the European Heat Pump Day, which is happening today. So let's go to our slides, and then even you will start presenting, if I'm not mistaken, a little bit a case study of how our industrial heat pumps are working in a brewery. And then, Benjamin, you will speak a little bit more about market trends and so on and so forth. For you guys who are on the other side of the screen, remember that we will answer your questions live. So please don't hold back. Don't hesitate asking questions. Our colleagues, our experts are here for that, for answering your questions. So yeah, feel free to ask any questions. We will take them as long as we go. So Ivan, let me jump to your slides, please. Okay. So let me know when you're able to see, or even if you want to share the screen, even you can do it yourself, so you can have the ownership of the slides, I would say.
Yes, I almost prefer that. I hope that everyone is able to see my screen in presentation mode.
Yes, we are able at the moment. That's it, correct?
Oh, okay. Thank you. So let's get started. There's a lot we can talk about industrial heat pumps and decarbonization, but let us get the basic start. So there are various applications split in different temperature ranges in the process industry, which can be addressed with heat pumps. Up to 100 degrees centigrade applications can be addressed already for several years with mature and market available technologies. This is not new. It has been on the market for a while. What is coming in, and we'll focus a little bit further in the discussion today, is the next step, which is industrial heat pump technologies, which can get us above 100 degrees and up to 150 degrees. Target is to generate steam, low pressure steam. There are already available technologies for these applications, but there is more development coming in the, I would say, 1 to 2 years. So far, so good. We have the technologies, but where can we use them? There is a large list of industrial applications which we can start with, but where would be the lowest hanging fruit? In our view, and thanks to Cordin's really excellent overview here, food, beverage, and tobacco is an obvious place to start. Several reasons. In the range of low pressure steam, 100 to 150 degrees, food and beverage and tobacco has the highest potential. Almost all processes in food and beverage can be solved up to 150 degrees. Secondly, all, to my knowledge, food and beverage applications require also refrigeration, which means that the end users already have experience with refrigerations or with refrigeration systems, also with refrigerants, also with servicing. It is obvious solution to put heat pump on top of the refrigeration system or a refrigeration cycle on top of the refrigeration system, target decrease use of fossil fuels and reuse the excess heat from the refrigeration cycle. There are also,
Ivan, so sorry to jump in. We're on slide 2 here, and we don't see the slide in the presentation mode.
Oh.
So I know you're talking about slide 3, but we are on your slide 2.
Really? Thank you for jumping in. Let me try to reshare. This is one of the challenges of really live stream.
Yes. In the meantime, if you want, Ivan, we have received a question from Erwin in Melbourne, Australia. He wants to know if we are going to touch base on natural refrigerants during this session.
Oh yes, definitely. Our focus in new technologies applications is natural refrigerants, as well as other environmentally friendly refrigerants such as low GWP refrigerants. In fact, if we want to generate steam or going to temperatures above 100 degrees, there are basically two types of refrigerants. There are natural refrigerants, namely hydrocarbons, or low GWP refrigerants. So we indeed will talk about developments with naturals. I hope that you'll be able to see my slide 3 here with the table of applications.
I think you are sharing the wrong screen again.
It was working better in the preparation, I must say.
No worries. That's the issues of being live.
Yeah, we are very natural. Okay. Okay.
I think again you are sharing the wrong screen. I think it's the one with the with the Restream platform, the one we are using for the live stream.
Okay, David, do you mind sharing from your screen?
I can, yes, of course. Okay, let me just move to the relevant slide. There we go.
Okay, can you please click up a couple of times so my animations appear? Okay. So I have been already talking about this slide, so I don't want to repeat it again. A quick summary: up to 100 degrees centigrade, all technologies are completely available. Above 100 degrees, there are innovations already partly available, various. And I would recommend to look into food and beverages, natural start of applying industrial heat pumps for decarbonization. There are many other industries that, of course, can benefit from heat pumps, such as pulp and paper, textile, chemicals. But if I have to pick up a place to start, this is food and beverage applications. Next slide, please. One example that I have prepared today is namely food and beverage application, namely a brewery where a couple of years ago were installed 3 heat pumps replacing existing and obsolete refrigeration system for cooling glycol and gas boiler, 3 heat pumps with natural refrigerants entirely with hydrocarbons for both process cooling and process heating, with 3 refrigerants, propane for cooling, isobutane for heating up to 100 degrees, and for steam generation up to 135 degrees or 3-bar steam is used butane. In this example, capacity is about half megawatt, and the system has been operating already over a year. There we have various components, starting with the compressors and also some line components. Important part here is that this application in food and beverage includes consecutive cooling and heating. And it's not only about brewery, the same logic, the same refrigerants, temperatures and capacities can be applied also for meat processing, dairies, fisheries, poultries, and many, many others. And the capacities vary from as low as 80, 100 kilowatts up to, I would say, high runners 1 megawatt per 1 heat pump thermal capacity.
If I may interrupt you, Ivan, I think we have received another question. I just show here in the screen about John. What are the most common myths about industrial heat pumps?
Yeah, that is a good one, and unfortunately, there are plenty. One of them is industrial heat pumps or generally heat pumps is immature technology. It's something new and unreliable. It's tests, so we don't know if we can count on it in future. This is incorrect. There have been industrial heat pumps for over 100 years. Over 100 years ago was installed the first heat pump of industrial size, by the way, in Switzerland. Then later on in the 60s, 70s, and especially 80s in Scandinavia, Sweden, Finland, Denmark, the last decades have been really growing big in heat pumps. It is very mature technology. The thing is, the market was not present there. Nevertheless, we see the market growing seriously now, and therefore there is fostering of the technology development. This is why also we target new applications and new temperatures. So yes, this is one of the biggest myths. Another one is that the heat pumps work only when the outside air is warm or not freezing. This is also incorrect, especially in industry where you go to refrigeration and you have both freezing needs. Then your evaporation is at minus 20, 30 degrees centigrade, and still you can operate your refrigeration and heat pump cycle. Yes, you may need to have a couple of cycles on top of each other. These are a couple of myths to get us going.
Yeah, thanks a lot. We have another question from Arun. I think I can take this one. He's asking if the presentation is recorded and the PDF is available. I mean, the presentation will be available on the live stream because it remains there and we will record it. But the PDF, we are not able to share it with you in social media, so it won't be available. But you are able to click on the event itself and access whenever you want. So in that case, the recording will be always available. So thanks for bringing this question, Aaron, and for the rest, please feel free to ask even more questions. Ivan, please continue with the presentation.
Thank you. And just to add to David, and please feel free to reach out to us or to your closest Danfoss salesperson. We will be happy to have a separate chat on heat pumps and make a further deep dive. So next slide, please.
Sure.
What development has been happening and are still ongoing so we can address these industrial applications, so we can completely get rid of fossil fuels? In the last years, we have been working on large scroll compressors on high temperatures, up to 100 degrees. Applications can be addressed with our new developments of scroll compressors with environmentally friendly refrigerants, hydrocarbons, and low GWP refrigerants. Applications, again, from 80 kilowatts up to around 1 megawatt system thermal capacity. This is also what we identified as highest furnace in the food and beverage. Obvious application is a booster system where you could use 30, 40 degrees waste heat and boost up to 80, 90, why not 100 degrees with a scroll compressor. What is also already available and launched earlier this year is our semi-hermetic piston compressor using natural refrigerant, isobutane, and delivering temperatures up to 120 degrees. So this is already a product in use and completely launched, which can be implemented in steam generation technology, right? You can deliver things up to 100 degrees and generate steam efficiently. What is at high readiness level development is next step going up to 135 degrees. Also, it's semi-hermetic piston compressor. We have various prototypes running in the field in labs, and this one is released target next year. What is exciting is since beginning of this month, we in Danfoss Compressors family have a new member. This is the Danfoss screw semi-hermetic screw compressor, which is targeting also heat pump applications up to, for the moment, 100 degrees centigrade. Going forward, we also will develop it for higher temperatures, 120 and 30 degrees, and capacities up to 1.5 megawatt thermal capacity per compressor. We are very, very happy to welcome on board this new product, as we realize that if we want to target efficiently industrial decarbonization, we need a complete portfolio. There is not one size or one technology that fits all. Therefore, we work on several tracks. And David, if you can go to the next one.
Yep. Before we move to the next one, you have been speaking about the different type of refrigerants that we can use in the different scenarios, and therefore we have received also a question from Bill Walton that he's saying what is the best refrigerant for industrial heat pumps? And yes.
Oh dear, this is a difficult one. It is not one size fits all. It all depends on the application. Many people are used to work with one refrigerant for many decades, coming from the refrigeration world, where the conditions have been constant. However, with heat pumps, you have variety of conditions. Your evaporating temperature and condensing temperature are changing. The lifts are also changing. Therefore, the refrigerants, the optimal refrigerants, are also changing. Let's not forget how do we evaluate what is the best refrigerant? Is it only COP efficiency? No, it is not only COP. It is total cost of ownership, which includes also the investment. What if one refrigerant gives you 5% better efficiency, but the required investment is 3 times higher? Then this is not business case, right? So it is not so black and white. We believe that there is not one superior refrigerant for heat pumps, but there is a best fit of one refrigerant in one application.
Super. Thanks a lot. And we have another question from Jesus Vallejo. And here I would also like to Benjamin to chip in here, because Jesus is also asking, what is the technology readiness today? And here I think that even you can speak from your point of view, but I would also like you, Benjamin, to also give your inputs here. So whoever wants to start with this question.
Benjamin, go ahead.
Yeah, I can comment on it. I think it's I mean, this is what it's all about, right? The technology readiness is today there are technology or technologies which are commercially available. We can see some of them here. They're available directly as compressors, or I mean heat pump systems based on those. But I think what has to be clear is that the market is let's say developing rapidly at the moment. It's really new technologies. Every week being released here, we are increasing in temperatures. The market becomes more competitive and so on. So it's really developing very fast, and I think that's what it's about. The market is becoming more competitive for a bigger range of applications.
Super. Then Ivan. Your turn.
And I fully agree. I fully agree here. This is why you see we have been also acting very rapidly in Danfoss, or at least as rapidly as we can. And Danfoss and the refrigeration industry, a lot has been happening. I would say a lot more has been happening the last 5 to 10 years compared to the last 50 years in refrigeration development. So indeed, exciting times for the industry here. If you can jump one slide, David, and go to my last one, because I'm looking forward to Benjamin's materials also. Next one, please. I already touched base on Danfoss screw compressor. This will allow myself to go directly to this one. What are the next steps addressing these high temperature applications in industry? We started a new UDP funded project at DTI together with Benjamin and his colleagues in Denmark, where with the other partners in this project, among others Fenergy, we will build a heat pump which can go up to 200 degrees centigrade, made of several modules, made of hydrocarbon module going up to, let's say, using propane up to 60, maybe 70 degrees hot water, connected in a cascade with butane, which can lift up to 130, 140 degrees with butane, another refrigerant, also hydrocarbon, also natural, and generate low pressure steam, which will be then recompressed by MVR cycle or water recompression, vapor recompression cycle up to 200 degrees. This is, in our opinion, extremely relevant for food and beverage decarbonization, where we can generate low pressure steam with hydrocarbons, among others, and if there is need for higher temperature than this 130, 140 degrees, we can recompress it with vapor cycle up to, let's say, up to 200 degrees. This is our target. What is new there for us? Well, new and old, because this is something that we have been looking for a couple of years. These are different compressor technologies, semi-hermetic pistons, already released to 120. Next step is 130, then going to 150. Danfoss screw compressors going to larger capacities. In this project, we target developing a unit of half a megawatt thermal capacity, starting with and going up to 1 megawatt. There are also, of course, other components. The compressor is where the application starts, but it's not the only component. Also heat exchangers and control valves and other stuff. This project starts now and will be ready 3 years from now, where we'll target installing it at the end user, which is also part of the partners. And this is actually my last slide that I wanted to make this introduction. I think it's a good place, Benjamin, to comment, as he has very, very large experience with this type of projects and development.
Yes, thanks a lot. Before we move to your slides, Benjamin, we have received 2 questions. Sorry if I do not pronounce the name correctly, Srinivasan, but he's asking what's the heating solutions available for the Indian market?
I would say that all of them are available also for the Indian market, as long as there is market interest. Actually, we already have been working with a couple of companies interested to develop industrial heat pumps to generate steam. In India, we already have a running prototype on CO2 as a refrigerant with a Bock compressor. In India for a couple of years, starting with 120 degrees. Next step is 130, 40 degrees. The CO2 is a very, very good refrigerant if the right conditions are there, just like every other refrigerant, right? The specific thing about CO2 is that you need a very low return water temperature if you want to deliver high supply water temperature. So this is an application which, if the conditions are there, it will be a super fit for the CO2. This is also why I didn't mention CO2 earlier. This is a niche application, but India is a good example.
Thanks a lot. And if we move to the next one is from Madhur. He's asking in the last slide why CO2 is not mentioned.
But I think that I was a bit faster replying to this one, Madhur. I did not mention it because I do not see CO2 in the largest picture, as often the water return temperature is at high levels, 50, 60, 70, 80 degrees, while CO2 is brilliant refrigerant if the right conditions are there, namely low water return temperature. If the return temperature from the process is 10, 15 degrees centigrade, then yes, indeed, we can use CO2 as a refrigerant and generate steam. And it is a good fit. But unfortunately, there are not many of these applications. Nevertheless, it can be used, yes.
Thanks a lot. We are starting to receive questions, so thanks a lot, you guys behind the screen to keep asking questions. But I want Benjamin to take this one because he's speaking more about trends and what growth do we predict in 2026. So I don't know, Benjamin, if you have something to add here.
Yeah, we definitely. I mean, it's how to predict the growth of a ketchup bottle, right? So there will something happen. It's a really complex thing looking at it globally. I mean, the uptake or rollout of heat pumps is really based on many aspects. It's, let's say, boundary conditions, economic boundary conditions. It's a pressure of end user through the supply chain. It's what technologies become available. So it's really many things here taking place. And yeah, I will comment a bit on, let's say, on these kind of aspects in my presentation.
Thanks a lot. But then, Benjamin, if you want to share your screen, we can proceed with your slides.
Yeah, perfect. I will just share it.
Good luck with that.
Does it work here?
It does.
Okay, perfect. Yes, Ivan, you already said it. We're working a lot with R&D projects. What I would say we are working with is actually bringing new technologies into application, and we do this by mainly three main services. So from DTI, we support technology owners in developing their technologies. This can be compressors, heat exchangers, or entire systems. We can test them here at DTI. We have quite an advanced test center where we can test everything from components to entire systems, from first of a kind system to standardized systems, everything from -50 to +200 degrees, and everything from a few watts to actually a few megawatts. I think we tested up to 3 megawatts here at DTI. And besides testing and developing, we do also integration, because if we work with new technologies, it's not always trivial on how to actually bring them into application. So we actually also have quite some experience on how to work with new technologies, how to integrate them most properly, how to de-risk working with new technologies, and so on. And yeah, with that, we are often asked, what do we have to do? I mean, you said it, Ivan, there's a lot of things going on. New technologies become aware. So what do we need to do to bring all these new technologies to the market? Well, of course, first of all, technology awareness, and many stakeholders have to be aware of what happens, what's possible with heat pumps. You said, what are the myths about heat pumps? Many assumptions, myths out there. So technology awareness, how to use these technologies, it's very important. And then it's basically three things. So it's technology developments are happening here. I will comment on this. Then I will have a look on end user adoption. So what happens actually at the end users? They are used to burn stuff. Now they have to go to something electricity based. So what pitfalls are here? What's done? How does this process look like? And then I will briefly touch upon the boundary conditions, what's happening here, because we can see that electricity is becoming cheaper compared to something you can burn. The subsidies are getting better, frameworks, incentives, and so on are there. And with all this in mind, we can see the market deployment is taking place. Technologies are being implemented, and there's of course some learnings there for new technologies. And this is very much what you said. I mean, there are technologies which are absolutely proven, let's say up to 100 degrees. We can also see commercially available technologies. We've seen it here up to 120, 30 degrees. We can also see first technologies coming on the market for up to 150, 160 degrees, and then also steam compressors even higher here. So pushing this curve, being on the forefront, there will be a lot of learnings along the supply chain. But let's start with having a look at the technologies. We did an overview here, which is already a few years old. It's based on this IEA heat pumping
Benjamin,
technology program.
Sorry to interrupt, but I think you are not sharing the full screen. mode, but just the slides themselves.
Just showing the slides itself.
Yes.
Okay, then I will share the screen instead, right?
Yes, please.
Let me see. Entire screen here.
Okay.
Okay. So what about now?
Perfect. Thanks a lot.
Perfect. Okay. Well, this is in the review of.
I think we are also having connection issues with
what we did as part of the IEA
Benjamin.
HPT
Can you hear
Annex
us?
58.
You were
Yeah,
frozen.
I can hear you. I can hear you perfectly.
Okay, it seems you are back. But,
Okay,
let's
perfect.
continue. Yeah.
But let's say when we started Annex 58, the situation was like we knew heat pumps could be built for temperatures up to basically no technical constraints here, really high temperatures, and we knew they're going to be the most optimal technology for maybe up to 200 degrees. And we knew this could be built, and we asked technology providers, why don't you develop these technologies? And they said, yeah, well, because no one is asking for it. And then we were like, okay, maybe no one is asking for it because you didn't tell that you could build them. and then we started to say, okay, there's some need for communicating what can be done. And this is why we did this review about what technologies are on the horizon, let's say, for the temperature range above 100 degrees. And we managed to find almost 40 technologies here. Again, it's a few years old. We're currently repeating it, and there will be even more than this. And well, there we saw that that's actually many technologies are becoming available and are being developed. There has earlier been a question about what are these technologies based on? We have seen the Danfoss portfolio, and we have seen what these technologies were based on. The first developments here, 2/3 were based on natural refrigerants directly, and some were based on HFOs, and some even back on HFCs. And when you then go in and dig a bit deeper, you can notice that many of those who are actually having the first developments based on an HFO product are developing an equivalent product based on hydrocarbons. And when I update this, I can tell you that there are only a very few companies left who have only HFO solutions and, let's say, dare to not have a natural refrigerant-based alternative. So I think the trends are clear here. That's going towards natural refrigerants. And then these technologies.
If I can interrupt you here, because there is a question also around technology use and also what kind of technologies on market developments do you expect for the coming years? And I think this is also aligned with what you are explaining at the moment, I would say.
Yeah, exactly. So I think many technologies are becoming available here for higher temperatures. That's what we did. I divided this figure into, let's say, up to 10 megawatts and above 10 megawatts. And let's say up to 10 megawatts, that's the kind of technologies we're discussing here. We have seen many products coming or being commercially rolled out up to 120 degrees. We see they are becoming preferred technologies here. We see that the technologies are being demonstrated up to 160 degrees, and it's being commercially rolled out right at the moment. And then above 160 degrees, there's maybe 1.5, 2 years delay or so. We have seen the project just being started here, with Danfoss also involved. So there are some things going on regarding the technology development, but I think there's also something about the market is generally becoming a lot more competitive. There are many competitors, technology providers coming on the market. The prices are also becoming more competitive. They're becoming more aligned. It's more proven technologies. There are more references cases out there. So this is really about bringing the technologies here onto the market. I believe these are really the main developments we see at the moment to build what's possible, because we really need it. Many have targets for 2030 already, and 2030 is quite soon. And the heat pumps here are one of the main technologies which need to be adopted.
Thank you.
We said it. You have shown an example of the projects we typically do, Ivan. Here's another example which has actually been done a few years ago. And that's a container which we tested here at DTI. And inside this container, there's a high temperature heat pump. And we have it with Bock Danfoss compressors here. So this is a G88, which you have seen before, with hydrocarbons, butane and isopentane up to 150 degrees. This is something which has been tested here. And then again, I'm talking about the scaling of supply chain. You have seen, okay, we have a system manufacturer included here. But of course, Danfoss provides to all system manufacturers which want to have the products, and you have seen the compressors being used. I believe they were also used in the case which you had from the Gulpener brewery. So this is what we talk about, demonstrating the technologies and then making sure to scale them across the market.
Exactly. If I can just comment on this one, this is exactly one of the couple of projects thanks to which we now have released the compressor up to 120 degrees. This is really a collaboration in the different bricks of our industry: manufacturer of components, test lab, research institution, end user, and OEM. We really need to work together, and that's a super example.
Mm-hmm. Perfect. Thank you for the addition here. And of course, there are also some other technologies here, some other manufacturers, similar targets, just to show, let's say, I said the market is becoming more competitive. So it's really a number of technology providers which need to be on the market to get it really competitive and available at broad scale. And we talk mainly about these technologies. You had Palladio for 1.5 megawatts here. But we're also talking about, we have, for example, also been involved in this with SKEA, where we demonstrated 4 megawatt heat pump to produce steam up at 140 degrees. And it's for sugar production, so it starts running now again. And here it's really in operation. You can see the big buildings here. So it's really big systems. And this is at utility scale. So a sugar plant, this sugar plant has, I believe, 70 megawatts heat load or so, and if you then imagine to be rolled out, it's really big capacities which we have in some applications. So it's really ranging from everything. We've shown it many applications with a few megawatt heating, but really up to utility scale here. So many technologies becoming available, and what's important, let's say, when we look at end users, well, end users, these are the ones I'm referring to who let's say own heat pumps. Is why I call them end users. So production facilities for food and beverage, for example, they are being urged, let's say, to decarbonize. But the market developments are there. There are some regulations which are being changed constantly. Incentives come onto the market. Gas, electricity price ratios are changing constantly. So this is giving some challenge for them to put a baseline for the decarbonization. And then we're talking a lot about heat pumps, but as much as I love heat pumps, I have to say there's no silver bullet, not even a heat pump. But we see a heat pump is always or very often a part of the final solution. And here it's very important to get an overview of what other technologies also to integrate: thermal storages, electric boilers, electric resistance heaters, and so on. And the order of implementing all these solutions for an entire site, it's very critical. So you typically need a decarbonization roadmap to really find a good way of how to decarbonize your systems. And then it's also here new technologies required. Much of the heat is required at these temperatures. And we're having first systems up to 120 degrees, but for some end users, they are very conservative. So there's still some hesitation to go for it. And it is not easy to work with new technology. So there's some end user confusion, let's say, at multiple levels. And this is where we really need to collaborate along the entire supply chain to demonstrate these solutions and to bring them into application. And we do it from DTI by supporting
sorry
them.
to interrupt you again, Benjamin, but we are receiving a lot of questions from the audience. So let's take some of them. There is a question from Aaron. It's quite long, so maybe we can take it on different steps. For district heating applications, is CO2 or NH3 aberrant, or is there any other refrigerants that are more suitable? That's the first part of the question. So let's go with this one, and then we can take the second part.
Yeah, well, as you said, what means optimal? Even said it. You have CapEx, you have OpEx, you have environmental impact. What I think is clear for district heating applications, you have a number of natural refrigerant-based solutions. You have CO2, you have ammonia, you also have hydrocarbons, which we see, and they are really dominating the market. So that's absolutely clear. And then which one of these is the most optimal? That's always a mixture of, let's say, how does the district heating company prioritize CapEx over OpEx, or efficiency versus investment cost? And then also, how are the boundary conditions? What are supply and return temperatures? What is your heat source? But it is, and this can, let's say, decide between these three: CO2, hydrocarbons, ammonia. But this is kind of what we see.
Mm-hmm. The second part of the question, I mean, it doesn't appear fully in the screen, but I will read it to you. It's that we have been speaking about CO2 heat pumps perform well when water return temperature are low. In which applications are such low return water temperatures typically found?
It can be, for example, sometimes in let's say district heating applications, but it can also be in industrial applications. There are, for example, industrial applications where you are preheating air or any other media from almost ambient temperatures, and then you are sometimes heating, let's say, a stream, hot water or air from 20, 30, 40 degrees up to, let's say, 100, 120, sometimes even 150 degrees or so, or even higher. And then you can take this share, which is in the range which you can cover. We have just seen here, let's say, a demonstrator for a CO2 system, which is for an industrial spray dryer for milk powder production. And this is where you then preheat air, let's say, almost from ambient temperatures up to 120 degrees. I think this is what it has been built. So that's one of the applications which is perfectly defined for CO2 applications.
If I can add something on both questions, starting from the second one. Sorry, another application which is very suitable for CO2 with low water return temperature is the domestic hot water. We see CO2 extremely suitable refrigerant where you need to heat up water from, I don't know, 10, 15 degrees centigrade up to 50, 60, 70, so high temperature lifts. And going back to the district heating topic, I think Benjamin explained it all on technology. It depends really on the conditions. On top of it is coming the way we want to control the system. How is the power supply? Do we have peaks in the grid? And here in Scandinavia, especially in Denmark, we have excellent example of a lot of installed wind power. And days like earlier this week, it was pretty windy, which means that we are peaking the load of power. So we either need to switch off the turbines or to sell the electricity for no money or to pay the users to use electricity, right? Well, I can imagine that if you have one massive big compressor, one very, very large heat pump, it is not starting very quickly if you compare it with, for example, several more flexible compressors using, I know, hydrocarbons mentioned, Benjamin, also CO2. You can have a very quick start, something that, by the way, DTI also has tested how fast you can start a heat pump and you can consume as much electricity as possible. Why? Because you can firstly program your heat pump to operate when the electricity is more affordable, but there are peaks that must be addressed within less than 15 minutes, less than 5 minutes and then the user of the heat pump is getting paid to use the electricity. So you basically can get paid twice. Once to use the electricity, another time to even sell the heat. So it's a completely new business model that also needs to be taken in consideration when we evaluate heat pump technologies.
Super, thanks a lot, both. There is also a parallel conversation in the chat about oil-free compressors and so on and so forth. We have a question from Srinivasan saying basically that what the max living hot water temperature possible with oil-free compressors with air 1, 2, 3, 4?
Yeah, let me take that one. It's not about the compressor technology, it's about the refrigerant. And the refrigerant at 28 bars, 1234 ZT, has a limitation of condensing at around 95, 96 degrees centigrade, which means if we assume a pinch of 3 to 5K, let's say hot water leaving at 90 degrees. Whether you use oil-free or standard compressor with oil, this is the limitation of a standard compressor with this refrigerant.
Perfect. Thanks a lot. I think that then, Benjamin, you can proceed with the presentation.
Mm-hmm. Yeah, I mean, just concluding on this one here, this is typically how we support end users, let's say, who want to decarbonize, because for them it's very important to know where their journey goes and how a decarbonized system for them looks like. Where should they have integrated heat pumps or other technologies? So it's typically this typical procedure of process mapping, concept development, technology assessment and forecast, pathway scenario building, and then de-risking and integration, let's say. And here it's very important, let's say, if you want to decarbonize as an end user, it's probably at least a 5 to 10 year journey ahead. And we see it that way too often they have a decarbonization roadmap, but their decarbonization roadmap of end users is often too, let's say, limited to technologies which are proven since years. And this means they are disregarding new technologies. And this is super stupid. If you look at a 5-10 year journey ahead and you limit yourselves to technologies which are becoming old, let's say, then you're really missing out. And this is something where we can help. There are some paradigms to take into consideration. I'm not going into detail with them here at the moment, but looking at the time just to share this, what is next? I mean, when we look ahead a bit, there's the industrial heat auction of the European Innovation Fund. This has been, the terms and conditions have been published last week. There is actually funding available. It will be an auction-based, let's say, subsidy here, where you can request a price in euros per ton of CO2 avoided. And based on the price you bid for this auction, you can determine if you get funding or not. You don't know where the boundary will be, but this is what it will be. And there's big money available. So there are 150 million euros available for technologies below 400 degrees in a range of 3 to 5 megawatts thermal, and 350 million euros for, let's say, heat pump projects, electrification projects above 5 megawatt thermal. And this is currently being published. We are currently seeing a lot of activities ongoing for this one here, and we're looking forward to see the deadline. I think it will be early next year, I believe somewhere in February or so. And we're looking forward to this, but this will certainly be a big thing for bringing heat pumps out there. And then everybody, you asked a bit for the technology overview. I said it is what we call Annex 58 is continued now as a Project 68. It's just a different name, but now it's called Project. And we're going to update this technology overview. And if you want to be updated here, just drop me an email or so, connect, and I can keep you updated on what's going on here. But by the end of this year, we will actually update a technology overview of the high temperature heat pumps, so everybody can see what has been done, what's happening, and what has happened during the last 2-3 years in this field. And then the last thing I want to share is an invitation to the High Temperature Heat Pump Symposium. You can see how many things are going on here. This is a picture from the last High Temperature Heat Pump Symposium. Last time we had 400 participants. Next time we will have even more. We have received 130 abstracts or so for presentations here. So it will be many presentations being shared, a lot of technical insights. This is meeting place for the industry, and I know also Danfoss will come there, and you are all invited to pass by and have a look at the presentations. But there's also some exhibition area where you can have a look at some compressors and so on. So yeah, make sure to visit the homepage, sign up for the newsletter, and register for the event. And I think this is what I had to have with you, and happy to answer some questions.
Yes, regarding the questions, we have a question from Edgar, where he's saying that the preferred refrigerant for 70 degrees supply, CO2 turns critical, propane cascade, pros and cons on efficiency, safety, and future GWP compliance. So it's a very, I would say, broad question, touch basing on different things, but if you can maybe answer a little bit here.
Should I answer, Ivan, or
go
you
ahead.
want to? I think it's very, very specific here. Again, it's preferred refrigerant. It depends a bit on supply return temperatures. I think if we talk about future-proven refrigerants, it should be natural refrigerants, in my opinion. So that's really CO2 and let's say propane cycles here. That's what we see for most of the applications.
Ivan, do you have something to add
Yeah,
here?
I tend to agree. We need to look into future, and future-proof is for sure natural refrigerants. I would also add to them the low GWP refrigerants. If we look into global perspective, not only Europe, but global perspective in the coming decades, there is strengthening the legislation for GWP. From this perspective, I would look more into, let's say, this 1234ZE, as the GWP is extremely low. 515B is a refrigerant that works technically. It's also not flammable at all. In the other hand, it's just below GWP of 300, and there may be insecurity. What happens in a few years? We're going to look into lower GWP, for example, in North America, going below 150. Then we need to change the refrigerant. Therefore, I would say let's from now look into natural refrigerants and low GWP refrigerants in the coming decades.
Super. Thanks a lot. We also have a question from Garrett. He's basically saying that how can the market adoption be accelerated? And maybe this is a question for both of you. I don't know who wants to take this one.
Benjamin, I think you have extremely good overview on market adoption.
Yeah, I mean, I can just share my view and opinion on it. I think it's basically through trust and collaboration. I mean, we can see that a lot of technology developments are ongoing, but on the other hand, we see that where we have end users who want to have new technologies, but please have them demonstrated, and others have references cases, have them, let's say, verified and so on. So we really see trust and collaboration here along the supply chain to be an enabler to work with new technologies. And if we do so, then we can really be at the forefront of the technology. And we see a lot of very, very good technology providers who are able to provide great systems, but just make sure to trust them and be open to new solutions, let's say.
And as you said earlier, Benjamin, it starts as early as education. I remember in my university times now, shamefully long 15 years ago, I remember that as a thermal engineer, I was taught that you need, exactly as you said, to burn stuff in order to get heat. No one told you that you can do that with heat pump. Well, you could back then, you can achieve even more now. So it starts early at all levels in the supply chain. So we need to work together.
Thanks a lot, both. We have also another question from Torben. He's saying basically which industries can address their application needs with heat pumps and which cannot.
Oh, that's a big question. Let me start answering. Well, as I started my presentation, the lowest hanging fruit, in my opinion, this is the food and beverage applications, as they already have refrigeration at place. There is demand to keep the meat cold or the milk cold as well. But you also need to process them with heat. Therefore, it is obvious that we connect cooling and heating with a heat pump and disconnect from fossil fuels. Also, the temperature requirements are not that high in food and beverage, such as in other industries, chemical, metallurgical industry, where it can go to several hundred degrees. And this also gives us the next part of the question, which industries cannot be addressed by heat pumps. If I recall from literature, applications above 200 degrees centigrade will be addressed by heating directly. So electrical boilers by electrical heating, as the COP, the efficiency will be very low if we look into the technologies. Up to 150 degrees, we are convinced that applications will be addressed with refrigerants, whether it's hydrocarbons, whether it's low GWP, and above 150, we see, with minor exceptions, primarily water, steam. Benjamin, what's your take on this?
Yeah, I mean, fully agree. And this is very much what we see now as the next step. And you said it, that's a low-hanging fruit. And to be honest, after low-hanging fruits, there are some fruits hanging higher up. And it doesn't stop there, because, I mean, we have to say that with, let's say, if we decarbonize everything up to 200 degrees, we are not yet done. And what we do, just to tell you an example, we have just launched one R&D project where it's about demonstration, where we talk about integrating a heat pump to heat asphalt. And I mean, if you talk about asphalt, well, you have an open drum which is being heated with natural gas, direct flame, radiation, and it's 1,000 degrees or so. And we say we can put a heat pump there. And if you explain it to people who know it, they are perfectly fine by saying, okay, you must be crazy, right? But what we can do is, if I tell you, okay, asphalt actually needs to be heated to 180 degrees. This sounds a lot better than, let's say, 1,000 degrees. And then we can maybe redesign a drying chamber which can take it. And if you look where the heat is used, asphalt is being heated from ambient temperatures up to 180 degrees. And 1/3 is used for removing moisture. And therefore, we do not need even 180 degrees. So 2/3 is actually below 100 degrees. And that's perfectly fine where we are talking about a heat pump now. And then you say, okay, yeah, but still asphalt has maybe 1,000 operating hours per year. It's still way too expensive. And then, yeah, well, that thing, this 1,000 operating hours has been designed for combustion-based systems. So let's say, what is done if we need to do something about the operating hours? Well, many are storing hot stones as thermal energy. So of course we have hot stones. We can just store them. It's building a silo. And then you have a system which has a good COP, can be stored at high operating hours. And this doesn't sound so crazy any longer. And this is so important to rethink the processes for heat pump-based heat supply. And again, this is not a low-hanging fruit, but this is just to show what's possible. And this will be the future in just 5, maybe 10 years. So let's look ahead and see what's coming here. And that's an example which is, let's say, showing the direction.
Great. We have also another question from Kim Omoda, and this is a more techie question. Basically, he's asking if you can mention one technical challenge for implementing industrial heat pumps in a large scale.
Yeah, a couple, at least. Let's look outside of the heat pump because, if the market is there and we believe it is there, we have been working on developing the components. So let's say that the black box called heat pump, we'll find a way to build it, right? What happens in integration, however, sector integration, this can be a challenge. For example, disconnecting the existing equipment for heating and connecting a new one, how you control the processes, or the existing process equipment, which, as Benjamin said, is designed to 180 degrees, even though maybe 100 degrees or below is completely sufficient. This implementation of the existing base and refurbishment on the process side, this is a way longer project as I see it. Another challenge would be electrical supply. We have seen sometimes large heat pump projects installed and being delayed in commissioning just because of weak grid of the power. So this scaling up may bring some additional challenges. What do you think, Benjamin?
Yeah, absolutely. I mean, to say short, a heat pump is only as good as its integration, and you can build the perfect heat pump. If it's integrated poorly, then there's not a big use of it. And I think that's also the main challenge: is integration has to be in place and the entire system around.
Super. Thanks a lot. We have, it's not a question, it's more a comment from Manuel Munoz. He's saying that basically the limit of the supply temperature for a heat pump is not totally the refrigerant, but the lubricant used in the compressor. With a poor selection, you will coke into the discharge. What do you think about this?
I fully agree, and I know Manuel. He's a really, really good expert in oils and high temperature, so he knows what he's talking about. This is a challenge, and challenge is both on the suction side, because if you have high source, high evaporation, then the lubrication is getting a little bit challenging, but also on the discharge side, if you have a discharge at 200, 250 degrees, that's something which, well, you can very well burn the the valve plate of the compressor.
Thanks a lot. And I think we have one last question. Maybe this is for you, Benjamin. What should be kept in mind for projects with novel high temperature heat pumps?
Yeah, I mean, it obviously, as I said, it really requires a proper integration, and you have a proper integration if you have a roadmap for decarbonizing. It's not something where you just look into a catalog and order heat pump and think, okay, this will work. You have to have a solid decarbonization roadmap, and that's, I think, what it's about. It's about a shift of mindset at end users coming from fossil fuels, kind of going over to electricity-based solutions. And that's something to be clear of. It really requires long-term planning and openness to new solutions to do things differently than what you're used to. And if that's in place, then you will find good partners who can provide you these heat pumps and make you having a good, sustainable business here.
Super. But then I think that was the last question we received. So thanks a lot, guys, for chipping in here on the occasion of the International Heat Pump Day. We apologize for these technical issues that we had at the beginning, where our host Bruno could not join, unfortunately. Again, remind you guys that this is recorded on our social channels. We are streaming on live on LinkedIn, YouTube, and Facebook, so you should be able to find the recording there. If you have new questions coming, don't hesitate to post them on the comments. We will try to answer them as soon as possible. Please expect some delay, of course. These two guys are really busy people. And I also want to especially thank you, Ivan, Benjamin, for taking the time to joining us during this day. Thanks a lot. Honestly, it was really a great, insightful presentation. We have learned a lot about industrial heat pumps. What is the market overview at the moment? What is the future? How it will look like? And yes, we are willing to have you back, Benjamin, with us in one of the next live streams. It was really a pleasure. So thanks a lot, guys, for being here.
Thank you very much for having me, and thank you everybody for the nice questions and the discussion. Happy to follow up.
Super. But then thanks a lot, guys, for joining, and remember to keep asking comments. We will answer the question as soon as possible. It was my pleasure to host this unexpected host in this live stream, I would say. But yeah, thank you, and see you in the next live stream, guys.
Thank you very much, guys.